Based Class 3470, Application and Server Support, Digest 3, System Management and Network Security. Due April 4th, 2018. Prepared by Noor Amin, Ryan Matthews, Colton Rumbolt, and Stefan Susi. Prepared for Thomas Rayner. The purpose of this lab will be to examine both the open source and proprietary software options available for the management of the security and system settings on the devices in our network. This will include us exploring how we can manage certain things like pushing updates and security setting parameters to the devices, and what it will look like to use in the software's interface that is provided. In the first section of this video, we will be exploring the management tools that we use to manage the antivirus/spyware settings of our client devices so they may prevent the likelihood of them falling victim to some form of virus. For our Windows environment, we decided to use the System Center suite of applications for our proprietary software option. The System Center Configuration Manager allows us to control not only the Windows endpoint security settings on our clients, but also allows for us to update other aspects of the clients as well. We will start off by taking a quick tour of the SCCM Management Console. First, we have the Asset and Compliance section. It is here where we can find the inventory of users and devices that make up our network. Later in this video, we will show how to populate this section with machines on our network. Next, we have the Software Library. This section will be used to manage and deploy updates or software to the devices on our network. This would especially be useful for a task such as pushing an application out to a specific group of users or devices that exist on our domain. We also have a monitoring section within SCCM that we can use to view various information about the software and security aspects of our clients. We can view software deployment information, distribution statistics, and see if any devices failed to download any of the pushed updates that we set on our network. Lastly, we have the administration section of SCCM. It is within this area that tasks such as managing SCCM accounts and permissions are set, setting up device/client discovery, and many other valuable options for fine-tuning SCCM for the needs of the network administrator. To push the SCCM agent out to our clients is rather simple, as it only requires 2 steps. First, we need to discover all the devices on our network by going to the administration section of SCCM and doing an Active Directory force discovery scan. Once the scan is completed, we should see all of our clients within the Devices area of the Assets and Compliance window. The final step is to right-click the client we want to install the SCCM agent on and select Install Agent. In the window that pops up, we can select any of the options we want and continue forward. These options are just used to either reinstall the agent or push out site software after the client has been installed. To verify that the SCCM agent has been installed on the client, we can look to see if the CCM setup service is running on the client or if the configuration manager shows up in the system and security area of the control panel. Now that we know the agent is installed, let's see how we can manage the security of the device. To view our managed security information, we will examine the endpoint protection area within the monitoring section of SCCM. It shows that one device is currently being managed by endpoint protection and that our security definition updates are being pushed out to the client. To verify our updates on the client, we can open up System Center Endpoint Security, or CCES, on the device and check when the last definition update was ran. As we can see, the last definition update was recent on April 2nd. We can also see within the settings of CCES is that we cannot make any changes to the configuration, as everything is shown as being controlled by the administrator. Finally, if we look at the update history of our client, we can see that the definition update was successfully installed, meaning that our security updates are being properly managed through SCCM. That covers our proprietary software section of this digest. Let's take a look at our open source alternative. For our open source security solution, we chose to use Puppet Endpoint Protection. It is a cloud-based tool that provides many of the same features as System Center Endpoint Protection. Now, let's take a look and see how it operates. Within Panda Endpoint Protection, we can see a basic overview of the status of our managed machines, such as the count of protected machines, problems or threats detected, and other miscellaneous information. Next, we can see the individual computers under our protection and view their individual statuses and details. The status page can also be used to view the details of our detected threats, including which hosts that they were detected on originally. We can also manually download the installers that we need, or we can instead get links to use to download the installers for endpoints that might not be presently accessible on the domain network for later use. We can also check on things such as our quarantine, or we can generate reports using a handful of standard templates to give us an overview of the network security status. The last thing we can look at with Puppet is the settings that we can set for the profile on our network. It is within this profile that we can set where the agent will be installed on the device and how we want our antivirus to behave, such as the scanning schedule and any exclusions that should be present. There is also the functionality for email and web filtering present within Puppet to be configured, but we won't be going too in-depth into that. The centralized client installation for Puppet is pretty straightforward. First, we install the distribution tool on one of our domain joined servers, and then from there, we need to set a name for the group we want to add our machines to, and then select which machines we want to install the antivirus agent on and hit the install button. Though we were given an error about a custom installer, we can simply ignore it for now and let the agent install. After a minute or two, we can see that the agent has been installed on our target host. If we swap over to the target host, we can now see that the Puppet endpoint protection software has been successfully installed and is running. After waiting a few minutes, we can see that the agent for our target, in this case DC2, is now reporting back to the management console that it is now being protected. Updating the endpoint agent is generally done automatically. This policy will have this configured by default and is generally recommended not to have it turned off. However, if it were turned off, the agent can be used to scan for updates manually on the client's machine. It is fairly fast and easy to scan for any updates. That concludes our section on Puppet endpoint protection. In the second section of this digest, we will explore 4 different types of system management software or management packs that we installed on our lab environment to manage our devices. First, we will examine the System Center solution for system management on a network, and that is System Center Operation Manager, which we will now refer to as SCOM. We will go over how we set up SCOM for the devices on our network and do a demo of which 2 management packs that we chose to configure for our environment. To discover the network devices within SCOM, we need to go to the Administration panel and right-click the Agent Management tool and select Discovery Wizard. We then select a scan for Windows computers and then set the automatic computer discovery for all the devices on our domain. From there, SCOM will then enter the discovery process and try to find which devices that are available on the network. After some time has passed, SCOM will display which Windows machine it found on our domain and which ones that we'd like to install the SCOM agent on. We will then wait for the agent installation process to continue forward. We can now view the status of our agent installation. Our Windows 10 clients failed due to compatibility issues, but it looks like our Windows 7 client and other servers work just fine. Though they show up as not monitored within SCOM, after some time has passed, they will all switch over to say monitored. With the client agents now installed, we can begin to install the management packs. To do this, we go to the Administration console and select on Management Packs in the left-hand column. From there, we then proceed to click on the Download Management Packs option in the right-hand column of the screen, and then from there we use the online catalog to choose which management packs we want to install. For our lab environment, we chose to download the Windows 7 and Active Directory management packs. Once selected, we just need to wait for them to download onto the server. If we go to the Admin console, we can see that our management packs for both Active Directory and Windows 7 are present. With the management packs now installed, it's time for us to test their reporting capabilities. For testing our Windows 7 management pack, we decided to view the report on the device's disk space usage. We can see that it can report information such as the size of the Windows 7 device's drive, as well as how much free space is available and how much space has been used as a percentage value. When comparing this report to the Windows 7 client, we can see that the information that it is outputting is fairly close to what is currently showing on the client device. This means that our Windows 7 management pack is working perfectly. When it came to test our Active Directory management pack, we noticed that it was a much different experience when compared to our Windows 7 management pack. We also chose to use the disk space usage report, but with this report, we had to specify a specific time frame for the report and a specific object to apply it to. In this case, we need to apply it to the Active Directory object on our DC1 server. We are now ready to run the report and view the information that it provides us. If we scroll through this generated report, we can see that this report provides us with information on multiple factors of the server's disk usage in terms of Active Directory data. Within this report, we can view more detailed performance data by going to Actions and selecting Performance View. From here, we can select different performance vectors that we like to show up in the performance graph. This could be things such as uptime, or even little small things such as the size of the log file. Through here, we have so many different options that we can use to view the reported information on the server, which could prove to be very useful when trying to troubleshoot issues on our Active Directory DC server. And here we now prove that our Active Directory management pack is successfully working. The first open source system management software that we will examine is called Puppet. Puppet is a Linux-based software configuration management tool that we can use to push files to the clients on our network. It provides us with the control and consistency we require in order to make sure that all the software is deployed safely and securely across our devices in the network. We will now continue to show how Puppet manages the devices in our network and how we can push a file out to all the clients that have the Puppet agent installed. Puppet doesn't have an actual management console to use due to the fact that it is a solely command line based application, but is still effective at managing the deployment of files and software to our clients. On screen, we have an example of a command that can be used to view the certificate list to show which clients on our network have established a relationship with the Puppet server to show that their agent has been properly set up and has had their certificate signed and connected. Before we can push any software, we first need to locate the Puppet agent for the operating system that we'll be using. We can actually go to the Puppet website itself and find the Puppet agent for the OS that our client will be using. After finding the agent, all we need to do is now download it and run the executable to install it on the client device. Once finished, the client will be able to detect and communicate with our Puppet server and have its certificate signed and set up to function with the Puppet server. Going back to the Puppet server, if we can see that there is a plus beside the client's name, it means that the certificate has been signed and is being currently managed. If we use the command that is displayed on screen, we can use it to sign any certificates for clients that are not currently configured yet. In this case, nothing will show up because all of our clients are being managed. With the agents installed, we can now begin to configure the file and software deployment through Puppet. To deploy objects using Puppet, we need to edit the manifest script which is used to push out the configuration to our clients. That script can be found in the directory that's presently on screen. With the manifest script open, we can view exactly what it is planning to do when it is deployed to our clients. We can see that it plans to create a file in the C directory called puppetmaster.txt. Within this file, we can see that it's going to have the contents that contain the lyrics to Rick Astley's 1987 hit, Never Gonna Give You Up. Though we are just pushing out a simple text file, this manifest script can also be used to deploy other items such as software or configuration options if necessary. Once saved, Puppet will push this file automatically out to the C drive of all the clients that have the agent installed within the next 30 minutes. Instead of waiting 30 minutes for Puppet to push out the file, to test if our Puppet is deploying the file properly, we can use the command puppet agent --test within the command line to force the client to grab the manifest script file from the Puppet server. As we can see, the file shows up in the C drive and contains the exact same data as what was shown on the Puppet server. This will conclude our section on the Puppet software configuration management tool. The final software that we used for our system management solution was OpenNMS. OpenNMS is an open source enterprise-grade network monitoring and management tool. It offers a variety of services for both not only monitoring the clients within our network, but is also capable of monitoring other types of devices such as networking hardware. We will now take a quick look at some of the features available through OpenNMS. When we first access OpenNMS via the web console, we will be met with the dashboard. This dashboard provides us with a lot of valuable information about the devices on our network, such as if any alarms or outages have been detected. It can also provide us with information on the availability of specific devices on our network, such as if any networking interfaces have gone down, or if any web, email, DHCP, or any other types of servers are experiencing any sort of problem. If we would like to find out specific information on the devices that make up our network, we can do this by going to the Information tab and scrolling down to Nodes. Once within the Nodes area, we can see all of the clients that OpenNMS was able to detect on the network. Here is where it stores all the information that it detects on any of the clients. If we select a device such as our management server, we can view details such as the availability of certain services on the server. We can see that it keeps tabs on our web, ICMP, and RDP services. If we click on one of the services, we can get more detailed information such as which ports that the service is using and any alerts that may have been triggered for that specific service. This area of OpenNMS would be a useful tool to help us detect why certain services may be experiencing performance problems by having us simply take a look at their service availability. When it comes to using the networking devices on our network, we can configure alarms and outages to let us know when specific networking hardware or their individual interfaces may be running into some issues. Within the alarms section, we can view a log of all the warnings or errors that were reported on the network. If a device that has SNMP enabled fails to communicate with the other devices on the network, the error would be located here. Also, if devices suddenly become unavailable to communicate on the network, it will create an alarm here as well. Next, the outages section of OpenNMS is an area that can be configured to alert us if there is a failure in the network path between two nodes managed in OpenNMS. As this digest did not have a heavy focus on networking, we were unable to test the outages functionality within OpenNMS, but it is something useful that we would like to potentially explore in a future project if we have enough time. OpenNMS also comes with a reporting feature for our client devices. When we select a device to run a report on, it seems as though OpenNMS will only pull its ICMP response time information. This is, however, an important piece of information that we can use for our network, as we can use this to detect if a client is experiencing some form of network latency. The last feature we'd like to discuss is the ability to create a network topology over a geographical area within OpenNMS. As OpenNMS is considered an enterprise-level software, it could be used to illustrate how different sites are connected to one another and provide a network administrator with a more visual representation of how their network is set up so it is easier to present to someone new. This concludes our findings on OpenNMS and will also conclude this section of the video. This will be the end of our video for Digest 3. Thank you for taking the time to watch the video. We hope you're able to learn a thing or two about system management and system security. If you have any questions regarding our video, please feel free to ask any of the members of our group. Until next time, see you then.